Okay, in this question, we are given that on a recent Saturday, a total of 683 people visited a local library, and then they tell you that from these people, 165 were under the age of 10, 216 were aged between 10 and 18. 222 were aged between 19 and 30, and last one is that the rest of them were more than 30 years old. So then the question is, one person is sampled at random or selected, it means selected at random. What's the probability that the person is more than 30 years old, and what is the probability that the person is below 19 years of age? So in order to solve this, first we need to ask the word that's bothering us here is this: the rest of them were more than 30. What is this number? How to calculate it? So we know that in total we have 683 people, and we are given that those are the people that are less than 30. So if we subtract them from 683, we will get the ones that are more than 30. So we subtract 165 plus 216 plus 222 from the total, and this would give us exactly 80. So this means that 80 people are more than the age of 30. You can put it back here. Instead of the rest, you can say 80 people. Okay, before I solve this question, it wouldn't hurt, and it would be actually nice if you would draw a frequency table for this data. So you would go like this and put the age here and the frequency, or how many people are in this age group. And so we would need 1, 2, 3, 4, 1, 2, 3, 4, and I'll add the fifth one for the total. So this will be the total. And so we are given that, let's use the same color as we have above. Less than 10, the age is less than 10, we have 165 people. And between 10 and 18, we are given 216 people. And between 19 and 30, we are given that there are 222 people. And then the rest of them, let's choose red color for the rest of them. We found it was 80. Yeah, so more than 30, bigger than 30 years of age, we found that there are 80 people. And of course, if you sum all of these numbers, this plus this plus this plus this, you should get the total that was given at the beginning, 683. So this would be 683. Now we can solve A and B. So on the next page, I will show you the frequency table again, but I created it to look much nicer than the one we had before. So look at it here. This is the frequency table that I just showed you on the previous page with the numbers there. And so the question is, what is the probability that, let's read A, that the person is more than 30 years old? So it means we want the person to be more than 30 years old. You ask yourself, how many people do we have that are more than 30? We have 80 people. Out of how many total? Out of 683. So you can say that the probability of the person more than 30 years of age is equal to, we have 80 people that are more than 30 divided by 683, and this would give you approximately 0.117, which is 11.7%. So let's keep this as our number, yeah? And if you need to do it as a decimal or a percentage, you know how to do it. Now let's go to the second question, part B. It says that the person is below 19 years of age. So let us delete the stuff that we used for the previous part and think about this part. Now, when you say below 19 years of age, it means that they belong to between 10 and 18 or less than 10. So I said or. So this means that probability that you are below 19 years is equal to the probability of being less than 10 plus the probability of being between 10 to 18 years. So the probability of being less than 10 is 165 divided by the total number, which is 683, plus the probability of being between 10 and 18 is 216 divided by 683, and this would give you 381 over 683. So this would be our answer, which approximately, if you compute it, it will be 0.5578, or as a percentage, this is 55.78%. And so this would answer the question. Notice that it was nice to do the frequency table.